The Core P90TG from Thermaltake features a unique prism-shaped open-air design so you can ogle your parts from any angle. The 5mm tempered glass keeps things classy, and the 3-chamber design supports a full complement of hardware even if you're custom water cooling. For more on the Core P90TG, click the sponsor link in the description.
Excellent!
What's up guys, welcome back to Paul's Hardware. Today's video is my follow-up to what was originally my February build, and I need to start off by saying a big apology to you guys because I know this is a lot later than I was originally intending to put it out. I've been out of the loop for a little bit, but I'm back, so thanks to all you guys for bearing with me. And today I'm going to show you guys a little bit more details about the setup of this build, and then I'm also going to do some demonstrations just showing you the basic performance. If you're planning to build a gaming PC and you want to do an APU-based PC because graphics cards are so expensive right now, I think this is a great solution for anyone who's just trying to get their foot in the door and then of course have a lot of upgrade potential in the future. So all the parts in this system were all assembled about a month ago, and the link to that video I'll put in the description, as well as a list to all of the parts that I've used. Now at the end of that first video I directed you guys over to my first 5 things to do with a new PC build video, and that should have helped you get things set up. But every computer that you build yourself is going to be a little different, might have quirks. So I'm going to start off with some things to know, and the one big one that I've already gotten a few comments on and a few tweets about is the potential BIOS incompatibility issue. So here's the situation. Right now we have these new AMD APUs, the Ryzen 3 2200G and the Ryzen 5 2400G. These came out in January 2018. The motherboards that they're compatible with are going to be your B350 chipset motherboards and your X370 chipset motherboards. Those came out a year ago. Now, if you happen to have an older motherboard, a B350 chipset motherboard or an X370 chipset motherboard, there's like A320 as well, but I typically recommend B350 or X370. Now, if your motherboard was manufactured and shipped to a retailer sometime in 2017, then it has an older BIOS version on it. And what you need to do is take your motherboard with old BIOS, update the BIOS on it so that it will recognize and be compatible with your new APU. This situation is going to happen again in another month or two once the Ryzen 2 processors launch. We'll have the same situation because you have a bunch of Ryzen 2 CPUs like theoretically the 2800X and so forth that will be compatible with existing B350 and X370 motherboards, but if the motherboard was shipped earlier and has an older BIOS on it, the BIOS needs to be updated first in order to recognize the CPU. That puts you in kind of a catch-22 situation because in order to update the BIOS, you need to install a CPU to get the board up and running. So long story short, older B350 motherboards that shipped in 2017 might need an update to be compatible with the newer 2200G, 2400G Ryzen plus Vega APUs, and in the future even Ryzen 2 CPUs as well that might come out. Most B350 and X370 motherboards have an updated BIOS available, but you'll need to install an older CPU first in order to boot up and update your board, and then install your 2200G or 2400G. So for example, the board that's used in this build, the AB350N Gaming Wi-Fi, if we go over to the support page on Gigabytes, you'll notice down here under BIOS, there's 9 older versions. And in fact, the first versions came out back in June or so. That was when the motherboard launched. And it wasn't until late 2017 or beginning of 2018 that we have Raven Ridge CPU support. So in December, and then we have some more updated ones that have come out after the fact as well. If your motherboard has a F5 BIOS or older, then you can't install and recognize a current gen APU into it. Now there are 3 solutions to solving this problem if you happen to be stuck in it. Solution 1 involves some forethought. So if you've already bought your hardware, then this probably won't help you. But before purchasing your motherboard, make sure the motherboard says AMD Ryzen Desktop 2000 ready. AMD has published some stickers that they might put on the box, or the motherboard manufacturer might put a sticker on the box that says Raven Ridge ready. This might be difficult to confirm with online purchases though, so you might also want to double check if you're shopping on Newegg or Amazon that they've put some extra text in there that indicates the motherboard that's going to ship to you is compatible or is updated to be compatible with these new Raven Ridge APUs. The second solution, if your motherboard has arrived and it's not updated, then it's just not going to work. You'll install everything like I showed you in the first video, and then it won't boot up or you get a blank screen. Now, if you don't happen to have a slightly older 1000 series Ryzen CPU on hand, your fastest solution is probably going to be your local PC repair shop. Most PC repair shops will update your BIOS for you if you bring the motherboard in. They might charge you a small fee. I've heard $5 to $15. And by the way, if you happen to be a PC repair shop owner out there, consider offering a BIOS update service for free, especially with the Ryzen 2 stuff coming out. It will make a good impression on potential new customers, and it is a great way to get that potential customer to hang out and browse your store for 5 or 10 minutes while they wait for you to do the very simple update. The third solution is direct from AMD, and they will actually lend you an older Bristol Ridge APU. So this is an APU that has older architecture, but it is functional. It costs about $60, $70 if you were to buy it at retail. But if you contact AMD, you send them proof of your purchase, and they will ship you a dual-core A6 9500. You can install that, update your board, and then they will provide a shipping label to return that loaner CPU back to them. It does take a week or two to get to you. Gamers Nexus recently tested this as a consumer. So if you don't have time to wait that long, then the first or second option are probably going to be a better bet for you. Now, since I knew I was okay on the BIOS update issue on this board in particular, I pretty much set up the system according to that first 5 things to do with a new build video. Now, I also installed an 8 gig memory kit. The original kit that I installed, if you guys remember, was a G.Skill Flare X kit, and these are each 8 gig DIMMs. And I wanted to test in the same configuration as I recommended to you guys. So I've just swapped out for these. This is just a G.Skill Ripjaws 5 kit, 4 gigs per DIMM, so 8 gigs total, 2x4, and that's so I could test the configuration that I'm recommending you guys actually buy for sub $500. Now, if you got the team kit that I recommended in the first video, then in order to get the memory running at the right speed, you can just go into the BIOS and plug in the XMP settings as per my first 5 things video. I actually went in and manually set the speed on this memory to run at DDR4 3000, so it would be the same speed as the kit that you might get at home, and that way we can hopefully get about the same performance as you might expect as well. Let me show you guys how I've set this up in the BIOS. So I've now jumped into the BIOS, also known as UEFI, and here is where we can change some of the core settings of the motherboard and how the CPU works and the memory frequency and that kind of thing. Now, this usually has a graphical interface, so you can actually use your mouse and your keyboard to navigate around. But for those of you who need to update the BIOS, just to give you guys a quick tip on that, you're basically going to need a USB drive. I recommend plugging it into a different computer and formatting it. FAT32 is the file format you want to use. Once you've got a FAT32 USB drive, go to that gigabyte download page I already showed you, download the latest update, put it on the USB drive, and then from in here, you can use the QFlash option in order to update, and that will basically access your drive. You tell it what the file is, and you can do an update from there. Since I don't have a drive installed, it's not even letting me do that, but wanted to show you where that's listed at least. Beyond that, I wanted to talk about memory. So here we can look at frequency settings. We can see, for example, that our CPU is installed and the clock speed on it. And here's where we would plug in that XMP profile, Extreme Memory Profile, if we wanted to. So just switch to profile 1 and you would be good to go. I didn't do that here though, simply because I did it manually. I just set my memory profile multiplier to 30, which gives us a speed of 3000, and then I set the cast latency to 15 because that is what the memory kit is actually rated for. Beyond that, you can do the other stuff that I mentioned in my first 5 video, browsing through the BIOS if you want to. I would definitely recommend checking your boot options, making sure that that's proper. I've only got 1 option for booting. I've got 2 because I plugged in an external SSD as well. But beyond that, Windows installation, everything should go the same way that I showed in that video. So let's save and exit. And now here we are back in Windows. I've skipped over a lot of stuff just because it's included in that other video, but went to the Gigabyte website and downloaded drivers where applicable, specifically for the chipset and that kind of thing. Those have all been installed and I saved them here. Also got the Bluetooth and the Wi-Fi installed there. I did want to point out for this motherboard in particular, there appears to be a minor glitch that might happen with the default Wi-Fi drivers that Windows 10 downloads. So definitely go to the Gigabyte website, download those Wi-Fi drivers, and install those because they definitely are a lot more stable for me. Beyond that, you're also going to want to make sure that you have the proper driver for your what would be the graphics card, but since it's the APU, it's included as part of the CPU. But for that, you can go over to the AMD website and go to drivers and supports, and you can do the automatic detection thing. If you want to, I tend also like to tell it manually that I have an APU and that it's a desktop APU and that it's a Ryzen 3 with Vega because it's the 2200 and I'm using Windows 10 64-bit. And there it will give me the results. I can double check down here that it's the proper actual CPUs that are compatible and then click on download there in order to install that driver. Once that package is installed, you can right click on the desktop and go to AMD Radeon settings, and here you can access some of the functions of the Radeon software, such as the Radeon overlay. You can establish profiles for different games that you play, how it handles video, for example, display scaling, that kind of thing, as well as just looking at your system setup, whether it's the overview, software it's installed, updates for like OpenGL, OpenCL, and Mantle and Vulkan, for example. And then also you can look at the hardware that you have installed, which if you have the 2200G is a Vega 8 graphics unit, and you can see different revisions and other stuff in there. Now, one of the functions in the BIOS is to assign your integrated graphics a certain amount of memory that's allocated from the amount of memory that you installed. So since we have 8 gigs of DDR4, we're going to allocate some of that that's specifically set aside for the video or video card, and the rest of the system can't use that. So that's why if we were to, for example, go to my PC and look at properties, we could see we have 8 gigs of installed RAM and we have 6.95 gigs usable. Some of that's being used by the graphics and some of that is being used by system resources that you can't touch. Now, depending what you're doing with your system, 7 gigs may or may not be enough. So if we go over here to our task manager, we can take a look, for example, at the amount of memory that's being used right now. Of our 6.9 gigs, we're currently using 2.2 gigs just with the operating system up and running. We're not really doing anything. I mean, I guess I have Chrome loaded, so there's some Chrome tabs basically. But the point I'm getting at is that it's important to keep an eye on your system, what it is doing, how it is behaving, and what resources are being used. That way you can get a better idea of like, all right, is it time to upgrade or is this okay for my purposes? Now, if we actually go to logical processors, we can see the 4 cores of our processor and what they're doing. Task Manager is a nice basic functional way of doing this, but what I actually did for this system and for our continued testing today was I downloaded some additional software. So apart from our AMD Radeon drivers, I've also gone to the MSI website and downloaded Afterburner. And then I've gone to the Guru 3D website and I've downloaded the Rivatuner statistics server. I've also gone to hardware info, hwinfo.com, to download hwinfo64, and I'm running that as well. When I run all of those, it can give me a good idea of what's going on with my system, and the reason I'm using this software is simply because it's a little bit easier with this software to monitor stuff while you're playing a game. Now, there's a ton of stuff that you can do with this software, so I'm not going to go into all of it, but basically over here you get a view at a lot of different sensors that are on the board and what's going on. So for instance, your CPU is right here and you can see the different cores and the voltage that's being delivered to each core. You can also look at the core clock, and it's got a current, min, max, and average. So right now it's just idling, not doing much, so about 1.6 gigahertz. But when it actually ramps up, when you tell the CPU to do something, it's actually going up to about 3.7 gigahertz. And if we wanted it to go higher than that, then we could overclock to possibly go even beyond that. But I'll hopefully cover that in a different video. Beyond that, we can also see usage per core, and we can see that we've only really gotten up to about 63.4% usage on any core right now. That's because I haven't really done much with this right now. You can also take a look at your memory that's installed. We can see the memory speed here running at 1500 megahertz, or about that. Double data rate memory, so it's actually running at 3000 speed. And then we can also see our CPU temperature, for example. It's a good idea to keep an eye on that to make sure things don't get too warm. Then we've got more stuff from the motherboard. The motherboard has lots of different sensors on it, but if we keep scrolling down, we can find our GPU listed right here, the AMD Radeon Vega 8. Here we can also see GPU temperature, and we can also see stuff like the GPU clock speed, the GPU memory clock speed, GPU utilization. So what I'm going to do is tell Hardware Info 64 to use the Rivatuner statistics server to actually show the value for some of these things. And then when I load up some games, we can monitor these stats as we're playing the game. All right, so the first game I'm testing here is Grand Theft Auto 5, the classic GTA 5, which runs just fine on the 2200G. If a little bit less than 60 frames per second at low settings, or these are normal settings, at 1080. So I'm playing all the games at 1920 by 1080 today. GTA 5 is one you might consider just dropping the resolution down to 720 or something a little bit lower if you want a little bit better frame rate. But here's a look at the settings that I'm rolling with in GTA 5 when it comes to the graphics. We're at 1920 by 1080, ignore suggested limits, 60 Hertz, and pretty much everything else is set to either the lowest or normal settings, which is pretty much as low as it can go. So just a quick look at it there, and then also advanced graphics right over there. But I do want to point out when it comes to the on-screen display here, up in the top left, Direct 3D 11 here is just a frame rate, so we're looking for an average frame rate around 60 frames per second, above that if possible. Our CPU stats are also listed here so we can see the frequency, the load, as well as the current temperature. Memory, and this is system memory, we can see how much is under load right there, as well as the overall percentage. And then for our GPU, we can see the temperature, the frequency, as well as the load, and then I've got dedicated as well as dynamic VRAM. Dedicated is what we have told it to use, and then dynamic is if it goes over that, it can use up a little bit more. Now it comes to the memory for the graphics card, you can see the dedicated and dynamic. Dedicated is supposed to be what you assign to the graphics card that it will set aside for you to use. And then dynamic means if it determines that it's all being used up, it might use a little bit more up, and that means it's going to steal some from what's available for your operating system. So that is something to keep in mind. Right now we're only using about 4 gigs of RAM on the CPU side. So overall we're only using about 5 to 6 gigs, which means we're probably okay. But depending on the game you're playing, you might use more memory, and in that case is when you might consider a memory upgrade. So after driving down the highway for a little bit, I can tell that first off, we are definitely GPU limited with this game. We can see the GPU percentage there is hovering at around, well, just below 100%. So the GPU is maxed out. CPU, we're getting about 60 to 70% usage on. So that's not bad. It means we've got a little bit of headroom there, even though we're just using the quad core. And then beyond that, frame rate, as mentioned, it's dipping a little bit below 60 frames per second here and there, but overall, it's a pretty smooth experience. GTA 5 was a game that in my initial testing of the Raven Ridge launch, it was a little bit better suited for the 2400G compared to the 2200G, but again, it's still very playable, and even at the low settings, GTA 5 still looks pretty good. Voice chat muted. All right, next up we are playing PUBG, and always remember Control T to mute voice chat. PUBG is not a very well optimized game, and I discovered this in my initial video as well. It's pretty difficult to get a reasonably playable frame rate playing at 1920 by 1080 with the 2200G in this game. So to that end, I have gone and set all of my settings to very low, and you can see them right here. We're at 1920 by 1080, playing in full screen. Everything's set to very low. I got VSync off, so that's what we're working with right here. I'm already being attacked. Who's the guy? I think he is. Punch you back. So I'm gonna play through one round here. I think. Let's see if I can get a chicken dinner maybe. I've never won PUBG. All right, already I can tell that we're above our memory limits. We're using our full gig of dedicated VRAM, and we're already using 680 on top of that, as well as 5.2, 5.3 gigs of our dedicated RAM in the green there. So that's getting pretty close to like using up all the memory, and that's definitely going to be an issue with this game, especially as it seems like as I get closer to a town here, something with a little bit more structures loading in, we're just using up more and more. So if there is going to be something that causes the frame rate to tank, it's going to be having to fetch textures and that kind of thing from the storage drive. Even though it's fetching it off of an SSD, that can definitely impact frame rate. But anyway, I've at least landed, and we're bouncing back and forth between 16-ish. So I have a feeling our normal frame rate we're getting is a little bit above 30, which again is playable, if not ideal. But if you're seeing those dips where it goes down to like 16-ish or something like that, so you'll notice it's not happening right now, because I'm just kind of in an area that everything's loaded into. But when it was loading stuff, that's when we get the frame rate dips. I also have an Xbox controller plugged in that I did for Grand Theft Auto, which is why I'm seeing Xbox control commands pop up on screen instead of the normal keyboard and mouse, which is confusing me. Oh no! Alright, yeah. At least I threw a smoke bomb at him, I think, so obviously inspired some fear. But PUBG's challenging as it is though, especially with low frame rates, so let's switch over to Fortnite. Alright guys, I've moved over to Fortnite, Battle Royale, and right now we're just in the preloading area. Everything on screen is the same as it was before. We're in the bus now, so I wanted to quickly show you the settings I'm using. We're at 1920 by 1080 window full screen, and everything is set to medium. Although I'm only getting around 40 frames per second, so I'm actually going to switch most of this to low and off right now, just to see if we can't help ourselves out a little bit when it comes to the frame rate. That did seem to help. We're up to 60 now. So I'm going to attempt to play Fortnite now. I'm not very good at it. Wow, there's lots of people. Lots of people diving in. Should be fun. Alright, so we're using a decent amount of memory. We're at a little over 5 gigs of memory, and I should probably pick up those bandages, and I should probably have some idea of what I'm doing in this game. Beyond that though, video memory is looking pretty decent. We're not even up to a gig, which is one of the nice things about this game is it is not very difficult to play. You don't need a whole lot of system resources or anything like that, so that's definitely nice right there. We're holding pretty steady at 60 frames per second. In fact, so steady that I feel like VSync might be on. Hold on. No, VSync's off. Alright, VSync's off. It was just giving me real solid 30 frames, 30 FPS. Okay. What a jerk! Okay, well I died. Which is probably a good thing, because I was just getting distracted anyway. Point being, Fortnite Battle Royale, perfectly playable, nice solid 60 frames per second frame rate, as long as you keep the settings down to low. Time to jump into Overwatch here, and let's take a quick look at the settings I'm using. Full screen, again we're at 1920 by 1080. Overwatch has a pretty robust system for adjusting your settings in order to get yourself a good frame rate. So I've actually just gone and set the graphics quality to the low preset, and I turned off the frame rate cap. That shouldn't really affect anything anyway. And then the only other thing that I've changed is I've set the render scale to be fixed at 75%. If we're getting a good frame rate, I might bump it back up to 100%. That will give us the best visual detail, at least ignoring everything else. But all that said, let's go ahead and jump into a game. I picked Zarya. I usually go for Zarya or Pharah. I'm not sure why. Alright, we're just in the staging area right now, but getting pretty good frame rate actually. In the 80s and above 90s. So I'm going to real quick actually bump that render scale back up to 100%. And let's see how that does this. Oh, now we're around 60. All right, so maybe 75 might be a better option. This does make things noticeably sharper though, I will say that. 64, 66 right now. Ah. Surprised I lived that long, but okay. The fun thing about actually playing these games as I test them is that I completely forget that I'm testing a game, and then I'm actually playing the game and kind of having fun. More to the point though, let's take a look at some stats. RAM usage is a little bit over 5 gigs, so that's definitely on the higher side, but not too much of a concern, as again our frame rate seems to be holding at above 60 FPS, even with the render scale set to the max. Where am I being attacked from? Oh, she's like standing behind me. I wasn't even paying attention. So as I was saying, RAM usage is a little over 5 gigs, and dedicated RAM is using almost the full amount, just under 1 full gig for VRAM. So it looks like we're pretty solid there as well. Oh, did we get it? We got it! We won! I was nowhere near there, but we still won. That's what's important. Alright, so that was a lot of fun, and I haven't played Overwatch in a few weeks, so that's always nice. But I think at this point, I probably need to call things quits, and at least give a quick assessment. Good. This is a good little system. For the price and everything, I'm getting excellent performance, and I'm able to play these games. Granted, not at highest settings, but we're using an integrated graphics chip anyway. So, of course, there's going to be an upgrade path to that, and we can always make this system better if we want. but with this memory configuration and these settings, we're definitely kind of hitting the top end of where we want to be when it comes to like future-proofing and being capable of supporting higher-end games, for example. But it's definitely capable of playing them, and if you're a 1080 gamer and you want to get into PC gaming, this seems like a very, very viable solution. Alright guys, that is going to wrap it up for this video. I hope you have enjoyed it, and again, my apologies for it being quite delayed. But if you happen to build this system and get it all put together, then let me know what your experience was down in the comments section down below. Is it working well for you? If graphics cards prices come down, then I will hopefully do an upgrade path on this system as well, show what kind of performance difference you can get by installing a graphics card, maybe go into some overclocking if you upgrade the cooling solution. That's the great thing about building a new system like this, is it opens this pathway to all the other things that you might do with it, besides just playing video games, like I've been doing a little bit with today. But before I make this video too long, I want to say thank you again for watching. Thanks to all you guys who have been tweeting to me and asking me where I've been and that kind of thing. I have heard them, and it makes me feel warm and fuzzy inside. On your way out, if you can hit the thumbs up button, it's much, much appreciated. And thank you for watching. We'll see you guys in the next video.